list. Anyway, so today I want to introduce two new topics in C#, right? Number one is the idea of generics, and number two is the idea of exceptions in C#, right? So I'm going to just do a quick demo. It's only going to take maybe about 25 minutes, and we'll come back and maybe revisit this topic next week. In fact, we can't do it next week because it's bank holiday. So after Easter. Sure thing, yeah. This one? Yeah. Is that okay? Okay, so the whole idea behind this is that very often we need to make collections of things. Alright, we want to make collections, lists and arrays and dictionaries. And in order to do that, sometimes we want to make collections of strings, sometimes we want to make collections of integers. And in order to facilitate us being able to make collections of types and parameterize, so we can write the same code which implements the collection, and it can hold whatever type we want it to hold. So you might have already, in fact you'll have already come across this collection, which we'll do another time, but you go list, and you say, what do I want to hold in the list? Do I want strings? Do I want integers? Whatever. And this in programming, when you say I want a list of ints like this is passing the int type as a parameter to this list, and this is called generic programming. So generic programming is a feature of C#, it's a feature of Java, it's a feature of C++, it's not a feature of Objective-C, but it's in most of the big OO languages, right? So I'm going to show you how this is implemented. And in order to implement this, we're going to make a stack class, a really simple stack class. So I'll just click add class, and so you just type in the name of your class. So we're going to call this a class called stack, right? So we'll initially make a stack of integers, and then afterwards we'll parameterize this stack, so we'll be able to pass the type in and say, hey, it could hold strings or integers or whatever. So first of all, a public class stack. Now, I need some internal data structure to actually hold the elements that I want to push and pop off the stack. So for now, I'm just going to store those in an int array. So I'm going to go int elements, and that's fine. Alright. Now, I need to keep track of two numbers when I'm making this stack. Number one is the capacity of the stack. In other words, how many elements this stack can possibly hold. And then the next number I need to keep track of is what's the pointer to the current top of the stack. So first of all, I'll make I'll make a field for capacity, CAPACITY, and I'll make another one now for the top of the stack, and I'll set the top of the stack to be initially equals to 0. So what are the two operations that we can perform on stacks? You can only do two things. You can push things onto the stack, and the stack grows, and then you can pop things off the stack, and the stack shrinks. So if you pop the numbers 5, 3, and 2 onto the stack, what do you get? You get 2, 3, and 5. So you get them out in the opposite order in which you push them, because they always get pushed onto the top of the stack. So you get the latest one first. Is everybody happy with that idea? So let's make a constructor for this, right? We'll make a parameterized stack. And we'll assume that the parameter we're going to pass into this stack is going to be what's the maximum number of elements that we can hold, CAPACITY. And then when I pass in the capacity of the stack here, I need to do two things. First of all, I need to set the field so that I know what the capacity of my stack is. And second of all, I need to allocate enough memory to hold that number of elements. So elements equals new, and let's just make this a stack of ints initially. So equals new int capacity. So if I allocate this stack with 10 elements, then that means the maximum number of elements that I can hold on this stack is going to be 10. So we've got two operations that we can do on this stack. We can push things onto the stack, and we can pop things off the stack. Okay, so the top of the stack is initially 0, so that's where I'm going to start pushing things onto the stack. And every time I push something onto the stack, I'm going to add 1 to that, so that the next time it pops it onto the next free space on the stack. So public void push, so to push something onto the stack, and I'm going to push an int. So what do I need to do? I have elements here, and I need to add something to the top of the stack at position top. So top starts out at 0, and then I want to add 1 to top. So do I do plus plus top or top plus plus? Top plus plus, right? So I'm going to push it on initially at position 0, and then I add 1 to it. So the next time I go push something on, I push it on at position number 1. So it's going to be top plus plus, all right? It's going to be equals to what? And then I need a pop. So pop has got to return something, but it doesn't take any parameters. And what I need to do here is take the element at the top of the stack and return that, and then I need to decrement the top pointer. So do I do minus minus top or top minus minus? I think minus minus top, yeah. Okay, so that's our very basic stack implementation. Now we've got no error handling in here, and also it's not generic yet, but it's good enough that we can actually test it. Does everybody understand why we do top plus plus and minus minus top here? You know, if we imagine that we just push one element onto it, right? If we push one element onto it, then we're pushing it in at position 0, and top is now equals to 1. When we pop something off the stack, what we do is we take 1 and we subtract 1 from it, so it becomes 0, and that's the element that we take off. Does everybody understand that? Cool. We'll test out our stack and see does it work. So stack, my stack, equals new stack. And let's say that this stack can hold an initial count of 10 elements, right? So we'll push something onto it, my stack dot push, and let's push the values 1, we'll put a few different things onto it. We'll put 3 values onto the stack, and then we'll pop 3 values off the stack. So I can push 1, let's push 100, and let's push on the value of 8. So now my stack has got 3 elements on it, and now I want to pop 3 elements off the stack. Console dot write line my stack dot pop. So this is going to get the element at the top of the stack and return it. And at the same time, it's going to decrement the stack counter for us, right? So there we go. We're going to pop 3 elements off the stack then, right? So if we push on 108, when we do pop, we're going to get 8. Then we do pop again, we're going to get 100. And then we do pop the third time, we're going to get 1. So we get them out in the opposite order in which you push them. So there's our little stack, and when I jump in here, you see that I'm actually getting them off in the opposite order. So I get 8, 100, and 1. So you see you get them off in the opposite order. Is everybody okay with that so far? Does everybody 100% clear on the pre-increment and the post-increment, and why we use pre-increment and post-increment in that way? Because in the first example here, I know everybody hopefully gets this, right? But what we're doing is taking the old value for top. We're going to use that as the index. So initially this is going to be 0, and then we add 1 to it, so top becomes 1. So that then tells us the next place I'm going to push 1 on is going to be at element number 1. And in this case here, we need to actually subtract 1 from the top, because the top is actually pointing at the next free space. Does everybody follow that? Everybody 100% on that? Cool, so we've got a basic stack. Alright, so stack is pretty cool, but what would happen over here if I said, okay, that's fine, I've got a stack here, great. What if I wanted to make a stack, and instead of actually storing integers on it, I wanted to make it a stack of strings? Now, just knowing what we know so far, what could I do? I could maybe make a string stack class, I could make a subclass, I could use an abstract class maybe and have push and pop. It's going to get very messy. You know, or I could maybe use the object base class, which is the base class of all the C# objects. I don't know, does that work for primitive types? But here's a better way. Instead of making another class, right, and calling it maybe string stack, what you can do instead is you can say, you see this int here for the elements, and you see int what, and this int return type here, you can parameterize that. You can say instead of using ints, you can parameterize it so that, you know, that's actually a parameter of the construction of the stack. And here's how it works. Very simply, you just say, I'm going to parameterize it with a type T. And so when you're making your class, it's open angle bracket, whatever name you want to call your type parameter, and close angle bracket. And then what you do is, wherever you want to use this parameterized type, you just replace it with t. So instead of having an int array, we have a t array. And this could be int, could be string, whatever, depending on how we actually configure it. Now capacity, does that change? No, because that's always an integer, right? There's always a certain number of elements in there, and that always is an integer. And what about the top? That's not going to change either. That is always an integer, right? Because that's an index into the array, if you like, right? So, okay, so then we need to change this one. So instead of saying new int, it's going to be new t. And t could be int, t could be string, t could be whatever. And then we come in here, this what then needs to be t. Let's see.
What you're passing into the stack grid. Okay, stack, you have int capacity.
No, I don't think so. Because capacity is always an int. Capacity is always an integer. You know, because it's going to tell me the count of how many elements are in there. So it could never be a string or parameterized. Hey, do you know what? If you really wanted to, it's no big deal. You can just go t, tt, and then you can do tt, and you can parameterize it like this. So yeah, but I know it's always going to be an int. You can have as many different parameterized things there as you like. You know, this is saying it's a stack of int, but this number always has to be an int. So there's no point in doing in this example. But certainly we'll look at an example where in the built into C# is a dictionary type where you can do key values. All right, and that way you can say the key is a string, or the key is an integer, and the value is an integer, or an object, or whatever. So you can certainly have as many different types as you like, right? So now this is saying, and you see basically wherever I have int, I've replaced it with t, and up here at the stop I've said that t is this is how you basically say I'm going to pass the type as a parameter. You use angle brackets. Okay. Now this program ain't going to compile anymore, because when you create the stack, you need to say, what's it a stack of? So now you have to do stack t. Oh, sorry, stack int. And that makes a stack of integers for you. So now I have a stack of integers, right? And I'm passing this int in as the type that I'm parameterizing the stack with, okay? You can also make a stack now of strings, right? Stack, string stack. So you just go stack, open angle bracket, string, like that. And then, sorry, I'll get my angle brackets working okay. So stack, string, stack, string, string stack equals new stack of strings. So now, when I go string stack, string. Oh yeah, because of course you need to pass in the capacity of it, right? So you can pass in 10 like this. So you can go string stack dot push. So we can push on some strings now, right? So I could push on Brian, push on Mary, and Bill. So now we're going to get them off in the opposite order. We'll get them off in the order of Bill, Mary, and Brian. So now you go console dot right line string stack dot pop. So that's going to pop off the first string, and then we can pop off the second string and the third string. Everybody okay with that? That's passing a type as a parameter in C#, and that's the syntax for it, right? You basically set up your class, you use angle brackets when you're defining the class like this, and you say what you want the type to be called. And now the type parameter is named t, and everywhere you want to refer to the type that you've got, when you set up the class, you just replace it with t. Simple as that. Is that okay with everybody? Anybody want to ask any questions about that? So that's it. That's generics in C#. Right? There's nothing more to them than that. It allows you to parameterize, and it's most often used to implement what are called collections. So whenever you want to, lists of things and dictionaries of things and matrices, what we'll do actually is we parameterize the matrix class we've been working on. We'll make it a matrix of whatever. It can be a matrix of ints. It can be a matrix of strings. It can even be a matrix of matrices. Okay, So you can parameterize things like that, right? That's passing a type as a parameter. Now, next thing we want to do, say we take this little example that we previously used, and say we modify it, and I do this. So basically, if you look here, what I'm doing is I'm pushing on 3, but I try and pop off 4. What's going to happen there? Yeah, we will get what kind of an error? Will it compile? Of course, definitely will compile. We'll get a what?
Runtime error.
Yeah, we'll get an index out of bounds exception. So what's going to happen there? What's going to happen there is it's going to try and, if you look here, it will try and pop off at index number -1. Because it's going to subtract one too many elements from the top, so it will actually try and pop off at index number -1. So, if I run the program now, there we go, you get this index out of range exception. So you might have gotten these in your C# programs before. Now I'll show you how you can make them and how you can trap them. So the first thing is how to throw them. So it's a good idea to put this in your code, right? So first of all, this push should only work so long as top is less than capacity. Isn't that right? If top is greater than capacity, or even top equals to capacity, then we can't do any more pushing. So what you can say is, you can say, if the top of the stack is less than capacity, so let's think about this for a second. If the capacity is 10, right, and the top of the stack is 9, then you can't push anymore. Yeah, so if the top is less than capacity, we can push. Yeah, that's okay, isn't it? Less than capacity. Yeah. It just means that the top is now going to point at 10, but it means you can't push anymore. So that's correct, right? So we'll allow them to push, right? Otherwise, we have to inform the user, or we have to inform the calling method that something bad has happened. So how might we have done this before? Or in C, how would you normally do this? You want to write a method, you want to say, yeah, if something normal has happened, cool, we do it. If something bad has happened, what would you normally do? You return an error code, right? So for example, if you think of malloc in C, malloc returns null if there's no more memory left. So that's one thing we could do, we could return, but that becomes really messy. Because then what you have to do is every time you push or every time you pop, you have to check the return value. So it's a pain. So this idea of doing exceptions allows you to say, this is the normal run through the program, but if something bad happens, go off and do this. So that's what exception handling is all about, right? So what you can say here is, and here's 3 new keywords in C#. Number 1 is throw. TH4OW. Throw means something bad has happened, right? And I want to throw an exception. An exception is the object which informs the caller about what has happened, right? So what we want to do is throw a new index out of bounds, index out of range exception, and we can pass in a message to this, right? So you can say, could not push. Or maybe we'll just say capacity exceeded, right? Okay, cool. And then we need to do the same thing down here for pop, right? So long as top is what? Greater than 0. Yeah, so long as top is greater than 0. If top is 0, then yeah, we can't pop anything off. Then we can return this element here. Otherwise, we'll do the same thing. We'll throw an exception. And we'll throw a different kind of exception here. So we'll throw capacity of the stack, no more elements, right? That's what we'll throw this time. The interesting thing here is, you notice if you look up here, when you do the push, when you do the pop, I return this. If I throw the exception, what gets returned? Nothing. It doesn't actually return anything. What it basically does is it jumps from this line of code here to somewhere in here. Or if you don't actually catch the exception, the program will crash and the C# runtime will catch it. So here's how you actually catch the exception, right? So you can put this anywhere you want in your code, right? But you basically say try and do all of this stuff. you say try and do that. And if you can't do all of that, then catch the exception and inform the user. So you can catch the base class, which is exception, but let's catch the index out of bounds exception. Index out of range exception, E. And then there's a couple of things you can do with E. You can go console.writeLine, and you can write E.message, which is the message that gets passed in the constructor, and you can also go console.writeLine E.stackTrace. Alright, so the stack trace. What's the stack trace? The stack trace, have you never used the stack trace when you're doing debugging? The stack trace just tells you what methods called what methods to, at that particular line. So for example, I'll just show you what I mean by the stack trace, right? If you look at this here, say we're at push here, if I set a breakpoint there and hit F5, my program runs to this line here. Okay, it stops at the breakpoint. Look at this. This is the call stack. So Visual Studio gives you the call stack here. So it says, hey, you're at this line of code here. Look, line 24. And that's that line of the code. But that line of the code was called by this line of the code. Yeah, so this is the line, push calling the other thing. And so that gives you the stack trace. That's what's called a stack trace. Is that all right with everybody? But when your program is compiled like this for debugging, the stack trace is built into the executable, and all of that debug information is available at runtime. So I'm going to click debug and stop debugging here. And watch what happens. Here we're trying to pop off an extra element, right? So I'm going to put my breakpoint there, and I'm going to put another breakpoint there, just so as we can see this exception getting thrown. So I'm going to hit F5, right? Get rid of this previous breakpoint, F9, F5. And then what are we doing? Okay, so look at what we've done here, right? So what I've done at this stage is I've pushed on 3 elements, I've popped off 3 elements, and now I'm going into the pop method here to pop off the 4th non-existent element from the stack, right? So watch this, I'm going to press F11, which is step into in Visual Studio. And I can see here it goes, if top is greater than 0, but top isn't greater than 0, so it doesn't do that. Instead it throws the exception. So you go throw that exception. Now look what has happened. It has actually skipped all of the code. It doesn't do this, it doesn't do this, it doesn't do this, because the exception is thrown. So the execution jumps to the catch bit. So immediately from the throw, it will go to the block that is surrounding that, surrounding that. So it's gone to here, it's gone to this line of code here, immediately in this catch block, right? So now it's gone to console.writeLine, and this is where we are now. So now I'm going to print the message and print the stack trace. And it has skipped all of the code after that. Does everybody see that? So when you throw an exception, it will jump to the block that is surrounding it in a try-catch. And if there's no try-catch block surrounding it, the program crashes. Alright? So if you look at the console now, it has printed out no more elements. So that was the message that I used when I created it. And then here's the stack trace. Look at this, it says no more elements at blah 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 blah, line 40, and then this is the thing to call it. So it gives you the call stack in the program, that brings you to that line of code that threw the exception. Is that clear to everybody? Most importantly, as soon as you throw an exception, none of this code is going to get executed here. None of this is going to happen now. It will immediately jump to this line here.
Is that a string, the stack trace?
Sorry?
Is the stack trace a string?
Stack trace is a string, yeah.
Could you edit that string?
Uh,
write that line?
no, I don't think so. I'd imagine it's probably read-only. You could, I don't know, I doubt it. We could try it. Well, you could just go index, I doubt it, E equals new index out of range exception. I'd say it probably just gets constructed, and then I doubt that I'd say it's read-only. Yeah, I'd say it's read-only. It says, probably you're going to get an error saying that has to be an L value. In other words, I'd say it can't be edited. I'd say it gets created. Cannot be assigned to.
It's read-only.
It gets created automatically for you when you construct the exception object. Throw E. What do you think? Exception handling. Oh, one last thing in exception handling. I did say there was 3 new keywords. So there's try, actually there's 4. Try, catch, throw, and one last word is finally. Okay, so what's going to happen here is, right, the program gets to this line here, it throws the exception, so it's not going to execute any of this, it jumps immediately to where the exception gets caught. It's going to print out this, and then it will do this line here. So finally, this bit here actually gets executed regardless of whether the exception got thrown or not. Does everybody understand that? So this bit here always happens. This bit here is going to happen if an error occurs, and this bit here is going to get executed if no error occurs. Is everybody clear on that? Why do you think you would need something like this? Give me an example, a real world example. Huh? Yeah, you know, good example. Think about a really practical thing. Think about if you're loading a file, right? If you're loading a file, and say you want to process the file, right? So say up here you load the file, you do some stuff with the file, an exception occurs, you have to remember whether the file gets processed successfully or not, you have to remember to always what? If you open the file, you have to remember to close it. Okay, so whether the file gets, so you imagine, for example, you want to process a file of information, right? You might open the file at the very top of your method. You then go and process it. Oh, but say the file has got an error in it. You have to remember to close the file. So you might print the error, but you have to remember that whether the file got processed correctly or not, you have to always remember to close the file. So this would be a very typical example. Another example would be if you are doing some database operation, right? You might open a database connection at the very top, do an insert statement, but say you got an error in your insert statement, you have to remember to close the database connection at the end. So that's an example of where the finally clause would go. And then you put your error handling code here. What's the advantage of doing this try catch thing over just returning, say, -1? Because we could just return -1, and we could hash define, in C we might hash define -1 to say an error, and then you check to see if the error has occurred. What's the advantage of this? Rather than just say returning -1. Yep. It is definitely, yeah. I mean, it's very explicit, right? We're saying, okay, this is the normal case through the program, this is the exceptional case through the program, and this is going to happen regardless. So that's kind of the main reason why you do it. The other thing is, right, it actually separates the error handling code from the main normal run through of the code. When you look through this, basically this is the normal run through of the code, this is the error case. That's the advantage of it. It separates out the normal run through from the error case. Does everybody see that? Otherwise, you've got to put all this horrible messy code, which is the way C programs are typically written. You might go something like, in fact, it's such a pain to try and do this any other way. Because this can return an int. You can push -1 onto the stack. So what are you going to return if an error occurs, You can't really return -1 because that could be a valid stack element. And down here you could return a string error and then check for the error string. But it means you got to put if mystack.pop is equals to -1, print the error message and do something else. You end up with just very messy code with lots of if statements. So that's why this exception handling thing basically makes it for much cleaner code. Alrighty. So that's kind of summarized, the last 2 kind of major features of the C# language. Does anybody want to ask any questions about number 1, exception handling, or number 2, generics in C#? Cool. Alrighty, we'll leave it at that for today then, right? We're going to knock that off.